Hi, class. We're going to take a look at variables in C++. Now, in computer science, variables are perhaps the cornerstone of computing. They represent fixed allocations of memory, yet those memory allocations can hold a variety of contents. Not only that, those contents can change either through operations or over time or through whatnot. And that's the beauty then of computer science. We can then use calculations and other functions and even other programs to determine some output, some result, and then feed that into our program. So very powerful struct. They are found in every single programming language. And here's a quick overview on how they work in C++. Now, variables are nothing more than just a carved off piece of our memory. Now, when I say memory, we are talking about RAM here, as we remember from chapter 1, random access memory. That's where when we say we're running out of memory, that is our RAM that we're referring to. And if we run out of memory, then our program crashes. So when we declare a variable, and I'm going to just declare one over here, int value, well, what is actually happening is over in memory, our processor is going to carve off a specific chunk of memory just for this variable. So value now belongs here. It's an integer data type, and we'll get to data types in a second. And then let's say later in our coding somewhere, we assign a value to that. Well, then that value would go right here. And let's just say it's 15 for now. Now, different data types will have different allocations. For example, if we create an integer, then the processor is going to allocate generally 4 bytes for that. If we use a double, which is a number that's got any floating point precision or a decimal point and some numbers after it, that's going to be allocated 8 bytes. Usually a string is also 8 bytes, and that can grow. A character is only 1 byte because it just has to store one single character. And then same thing with a Boolean. Since a Boolean variable is just a yes or a no, a true or a false, a 1 or a 0, a binary variable, it just needs 1 byte. And we'll get to these data types in a bit. So that's how these get created in memory and sort of carved off and allocated. And for our purposes now, until we get into object-oriented programming in COMSC-110 and some more advanced data structures in COMSC-210, once we allocate those variables, they'll stay allocated throughout the execution of the program. The next thing we'll look at with variables is the fact that when we create one, they've got to follow the rules and have meaning. So what do these mean? Well, the rules for naming a variable are specific in C++, and these are also kind of the same in some other programming languages. The first rule is that the variable has to start with a letter. And for our purposes, we'll always say a lowercase letter, because later in your programming journey, when we get to object-oriented programming and objects, we see that class definitions start with a capital letter. And that allows us to immediately ascertain if some certain entity is class or object related or a native variable, like an integer. So they always start with a lowercase letter. And then once that letter is done, you can have any of these characters. You can have a number, I shouldn't say the pound sign, but you can have the digits 0 through 9. You can have A through Z lowercase. You can have A through Z uppercase. And you can also have the underscore character, and that's the only allowable character. Any other special characters are disallowed and will draw a compiler error. So as long as you follow these rules, then any variable name is valid, except A variable has got to be named something that's descriptive of its contents. So imagine you are in charge of a small team of coders, and one of your team members has submitted a bunch of code for you to review before it's placed into the next step of development. And let's suppose that we see a lot of code like this. As a team leader, you should probably be going ballistic by about now. And that is because these variable names have no meaning whatsoever. What does Z2 mean exactly? What is A4_6? And what does just B mean? So instead, we want to make our variable names as descriptive as we can of the contents that they're actually holding. So, if we have an int, if we're going to have an integer that is going to store someone's age, then let's call that variable age. So that's a much better name than, say, int a, and we're going to abbreviate it. No, just age. Or, if we're going to have some demographic data and we're also going to store height somehow, call it height instead of just h. Now, there'll be times when we use functions where abbreviated variable names are a convention, but we'll get to those. For right now, just get into the habit of making your variable names very descriptive. Okay, the next thing that we'll take a look at here is a convention for naming our variables when there's sort of more than one word involved. And our options here are to use either snake case or camel case, both named after some awesome animals. So what are we talking about here? Well, let's say we have a variable that's called tax. And it may not be descriptive enough to just call it tax. Because what does that mean? Is it tax receipts, tax income, tax rate? Is it a tax total? Is it a tax for income? We need more information here. So ideally, let's say that this is income tax, okay? Ideally, we would want to have both of those words as part of our variable name. So like income tax would be great. Income tax like that, and we could make this a double. So we would declare that like this, double, and then income tax. Except the issue here is that this word income tax is all lowercase and it's all mushed together, and a readability issue erupts in no time at all when you're constantly reviewing code. You need a way to bust these two words up so that they're apparent. And the two ways to do that are snake case or camel case. Snake case, we'll do it this way: income underscore tax. And you can see here then that the two words are all still in lowercase and just separated with the underscore character. And this sort of gives a sensation of a snake as we go on, because let's say we had an even more specific variable of income tax for year 5. Well, we can snake case our way all the way through that. And that's an outstanding variable name because it gives an accurate description of its contents. Now, camel case is where instead we're going to kind of follow the camel humps with respect to capital letters or not. And we would do that this way: income, lowercase, but then subsequent words are capitalized like this. So income tax, the tax would be capitalized. Or if we wanted to do that income tax year 5, we would do year 5, just like that. So that's our snake case and our camel case. It's your choice which one you'd like to use. I personally use snake case in all of my coding. The book follows camel case as a practice. So, you can pick either one you want. All I do ask is that you're consistent in your coding. So module by module, and then consistent within your program itself. Make sure that you've got a very consistent programming style with respect to snake case or camel case. Now here's a slide that I've got in the Module 2 compressed deck that just lists the 5 most common data types that we'll be using in our course. There are a lot more data types. Mostly you'll see that some of these will branch into other more specific data types. For example, integer as a data type has 3 or 4 other derivatives that you can use, a long integer, a short, things like that. Research the book for that. But for right now, the 5 main ones that we'll use are going to be int, double, char, string, and bool. And this slide has got examples for all of those. Now, we have to remember that when we create variables, that we have to tell the name right away and use a semicolon in that declaration. But the very first part of that statement is the data type. So that's why it's the most important thing to talk about first. Data types and variables are common throughout programming languages. And you can see how that's important because a compiler will need to know, well, what is this piece of memory going to hold? So it knows how much space in our RAM to allocate for it. So that's why data types are important. They also enforce operations. So for example, you can't add a string and an integer. And the other, I think most important reason is going to be the fact that we have to make sure that our data types are compatible, that they match. When we start dealing with functions, we're going to have return values, and those have to match by data type. If we're going to do an assignment, we have to make sure that this assigned value is of the same data type as what we're trying to assign. So quite important for those. Here are some more specifics on these data types. So an integer is going to store a whole number. And a whole number is one that has no decimal component whatsoever. If we do have a decimal component, even if that component is decimal 0, then we will have to use a different data type because an integer is only going to be a whole number. An integer can hold, for example, a counter. Let's say we're going to count the number of times that something happens. Well, an integer is perfect for that because we're only going to count 1, 2, 3, and those are whole numbers. Same thing if we're going to have something that we might increment later. Let's say we have an age variable, and if someone celebrates a birthday, well, then we have to increment age by 1. And an integer allows us to do that because an integer can be incremented automatically. Now, if we do have a decimal component, well, then we'll use a double. Now, there's also a data type in C++ that's called float. I'll write that here, but I'm not going to teach that, and we don't use that often. And the reason is because, a float has got a smaller memory allocation. And because of that, after about 4 or 5 decimal places, it starts to lose some accuracy. Whereas a double is an allocation that's double what a float would be. And it allows us to store bigger numbers and to store more accurate numbers. So we'll just use double in ours. And again, that's for any number that has a decimal component, like 12.052, or even if it's 136.0, well, that's also a double, even though 136 without the decimal part could be considered a whole number. So now we have to remember that if we're going to assign a variable, a number to a variable, they have to match the data type. What do I mean by that? Well, let's say if we've got integer weight. And then if I said later weight in an assignment statement, equals 152.6, well, the compiler is not going to like this at all, because weight is defined as an integer here, and yet we are trying to assign a number to it that's not an integer. We're trying to assign, in this case, a double, and that's a type mismatch. So we've got to remember, oh, this is an integer, so I can only assign an integer to it. So weight has got to be an integer. So this would work. Weight equals 153. That would work there because we're assigning an integer. Now, a string is going to be a collection of one or more characters. I can actually refine that and say a string is a collection of 0 or more characters, because you can have an empty string. A string is going to be mainly used to store just collections of characters into a single entity. And what do we mean by a collection of characters? Well, maybe it's a name. If I said string name equals, and then in double quotes, Joe, that assigns the characters J, O, and E together and puts them together into a string, and then assigns them to the variable name. That's what a string will do for us. We can put in uppercase, lowercase, digits, special characters, spaces, anything we want inside of a string, and it'll just be considered part of the string. A common thing that we might see would be a string for a full name, and that might have someone's full name, like that. Maybe a string for address, and that string could be something like, 123 Maple Street. You get the idea there. Those are all valid strings for us. Okay, our next data type is a char, and that stands for a single character. Now, with a string, you have to use double quotes. With a character, you use single quotes, and that's how it knows the difference between these data types. So remember that little rule. It can cause an error that sometimes is tough to track down if you forget these little rules. So, char, let's say grade is going to be an A here, because of course you all are brilliant and you'll be getting A's, I'm sure. So this is just how we declare it and then assign a value to it. Now, a Boolean is just a true false variable. If you actually output the variable, it'll print out a 1 if it's true or a 0 if it's false. It's all binary. And let's say we want to say bool status. We want to maintain a status. And if it's good, we'll call it true. If it's bad, we'll call it false. And here we would just do that. Bool status equals true. And that way we can use that variable status later in various kind of conditional and branching statements where that would have a lot more meaning and context. Okay, we're in a REPL now, and we'll look at some actual code. Let's first start with integer again. int is our code for it. And the way that we declare it is just we do the data type first, the identifier second, and that's it. Follow up with a semicolon. And what this means is that this variable called age, it's an integer, it has been declared. So as soon as the compiler processes this, that piece of memory is reserved in memory until the program finishes executing. So this is a declaration. I'm going to go ahead and put a comment here. You can put in comments in your code, and comments are characters that are not compiled or executed. And the 2-letter sequence in C++ for showing that we've got a comment starting is the 2 forward slashes together. And what this does is the compiler then will ignore everything from those 2 forward slashes to the end of the line. Now, we can do a declaration. The problem is that if we were to output age right here at this point, an interesting thing happens. Let me try that again. We get a random large number output. And the reason is that here we have in line 5, we have declared this variable age, but we never gave it a value. And now we're trying to output here a variable for which there's no recorded value. So what C++ does and many other languages do is it tends to make up a very large positive or negative random number. And that should be your code or your cue that you forgot an assignment in here. So a declaration needs an assignment, and we do that just simply with syntax that looks like this in line 6. Age, and that's the variable that we just created. And then we'll use the equal sign. The equal sign in this case is the assignment operator. Let me say that again. The assignment operator, because it's assigning an integer literal 15, it's assigning that to the variable age. Now you'll have to remember that if we tried this here, this will give us an error and we see, oh, there's a bunch of error messaging over here. And if we read that, we see that, okay, there's a previous definition. Well, what does that mean? And then when we hover over it, we get another clue. Well, there's a redefinition of age. And well, how can that be? I'm just trying to assign 15 to it. And that's because we repeated age 15. I'm sorry, we repeated int age, because whenever the compiler sees int and then some kind of identifier, it's going to create an integer. So here it saw that int age in line 5 and another int age in line 6, and it said, oh, there's two variables of the same name, and I can't do that. So make sure that your assignments are clean and that you're not trying to do two declarations by mistake. So that's how to do a declaration and then an assignment. Now, if we were to do a double, let's say double rate. Here I've created a variable that's a floating point number rate, and it's going to store 1.24. And let's output this here. And you'll see that our 1.24 is output successfully here. Now note though, and I'll put a comment here, that we did, and let me do one more comment up here. In line 9, we did a combined declaration and assignment. It's sort of like we took lines 5 and 6 and smushed them together into a single statement, which is exactly what we did. So here we're saying rate, double rate is what declares the variable, and then rate equals 1.24 gives us the actual assignment that 1.24 is being stored now in the variable rate. Now, there's some extra rules that you can leverage to your advantage. Let's say we wanted to do a couple of doubles, and let's say that they're just going to be rate 1, rate 2, and rate 3. Well, we can declare variables in one line multiple times like this. So here in line 12, I declared rate 1 followed by a comma, not by a semicolon. A semicolon terminates a statement. It says, okay, this statement's done. And that's not what we want to happen here. A comma is just going to be used to separate entities in a list like this. So it's going to create rate 1, rate 2, and rate 3. Let me copy this code down now. Oops. And let's see what kind of output we get here. And sure enough, we got this gobbledygook output, a very, very small number And why is that? Well, it's because we didn't do any assignment. So let's do that first here. Rate 1 equals 5.5. Rate 2 equals 6.6. Well, let's run that now, and we'll see that we'll get a 5.5, a 6.6, and then another gobbledygook number because we still haven't defined rate 3 or assigned it. Now, look at a little trick that I'm going to do right here in line 11. Right there is I'm going to instead initialize rate 3 in that line, and that works. Now we've got 5, 5, 6, 6, 7, 7, all properly containing some value and then properly outputting it. We can do that for any of them or none of them. Let's say I want to do rate 1. Not rate 2, but rate 3. And rate 2 I can do later is a 6.6. Well, here then we get that correct output, 4, 4, 6, 6, and 7, 7. Now, a reassignment is where we just give a variable a different number. So let's say I want to reassign rate 1. We can do that. And here we'll see that 100.24 in our output. And that's because here, even though in line 11, we assigned 4.4 here to rate 1, well, what's happening is in line 13, oops, let me draw that a little better. In line 13, we are reassigning that variable and giving it a different value. So when it comes time to output rate 1 here in line 14, it's going to print out rate 1 as of that moment in time and whatever's being held in memory at that point, which is 100. All right, so that's a double. Let's take a look at strings. There. Here's a couple of strings that I'm creating. And we can follow the same rules if we wanted. I'm again doing the combined declaration and initialization. Initialization is the first time a variable is given a value. So here we've got the combined initialization and declaration. We could easily do this instead. A declaration first, and then an assignment afterward. So this will create those 3 string variables. Note that each is constrained or bound by a set of double quotes. Let's suppose that we wanted to actually have a string that's got a phrase in it, like this. So the issue here is, we want to have a quotation within this string here, but the sets of double quotes are kind of conflicting with the proper set of outward quotes. We definitely need a starting double quote, and we definitely need this ending double quote right here, but we absolutely still want to print out some output there that has got the double quotes. So what we do is we can use a special operator for those, saying don't literally or don't consider this double quote mark as a terminator for a string. Instead, consider this double quote mark as an actual character that's to be printed. So then here is our output, and you can see there that we have those double quotes in there that are properly being output and properly being handled. So remember that little trick. This is an escape sequence. Anytime you have a backslash in some character, then it's an escape sequence. And now I'm going to print this out twice, like that. And we'll see in the output, of course, that we will get those statements output together. He said, don't go, he said, don't go, all together. And that's because we did not put in an end line character. So we can do that a number of ways. We can put in the end line manipulator here, and that'll bust them up. Or we could put right before that closing double quote, we could put in another escape sequence of an escape character of \n. And that's the new line character, and that gives us the behavior that we wanted. All right, characters are single characters. Let's do grade. And of course, it's an A because you all are brilliant. And there is a grade variable, just storing one single character. And characters we delineate differently from strings. Characters are single quote, strings are double quote. And there, when we output this, we'll get an A, and there we see at the very end that A. And as expected, a character is only going to be one single character. If I tried to put two characters in here, well, it's not going to like that one bit. And you can see that the output it just gives the last character, and that we get some angry messaging here. So just remember that a character data type, in fact, just stores one. And then finally, there's Boolean. And here's a short example of that. We'll be using Booleans a lot later when we start to get into branching, when we get into some conditional executions, when we get into looping. Maybe we've got a certain condition that's been met and we need to break out of our loop. Well, we can use a Boolean variable to keep track of that status. So here I've got in lines 30 and 31 a typical declaration and assignment. And you guessed it, we could just as easily do this, combining both of those together. And here we just simply output whatever that is. Now, I mentioned before, excuse me, that a Boolean only has two states: yes, no, off, on, high, low, 1, 0, true, false. And the compiler will always equate a true to the number 1 and a false to the number 0. Specifically, in some higher applications in computer science, a true is actually defined as anything other than a 0, and a false is a 0. But for our purposes, we'll just treat it as 1 and 0. So, that's a quick overview of a number of things relating to variables. First, we looked at how to declare them, how to give an assignment, how to output them. Watch the other video for doing math operations. And we'll see, we also saw, different ways to accelerate our coding, make our coding a little more concise by combining the declaration and initialization. And we looked at strings, characters, and Booleans also. So hope this all helped. And as always, pop a question into the module discussion board if I can answer anything else from this. All right, thanks everybody.